Hi all, this is Mr. Yeager, and we are on to our unit on acids and bases and equilibrium if you're in my class as well. But we are looking at acid and base properties. This is a fairly quick presentation. You're going to see we're basically just going to go through a list of different properties for acids and bases, and which is the normal way we kind of start off with going, what does an acid do, what does a base do? And we will kind of just hammer on through it. Again, this presentation was made by another wonderful chemistry teacher, and here we go. So, in our class, we would try to have the students create some sort of graphic organizer to separate out basically acid, neutral, and base properties. So if that's something that while you're watching you want to do, that's fine. But here we go. So we're just going to kind of list through, and you put them in the column that they have for it. So, this is what it says. As each characteristic is presented, decide if the phrase describes an acid, base, or neutral solution. Okay? All right. So, if it is not corrosive, if it's a chemical that does not corrode the object or something else at all, that would be under the neutral column, okay? Because that's basically water. I understand water, yes, can cause things to rust and other things like that. That does happen. But it's not going to necessarily react quickly, okay, with it. So it's not really going to start immediately corroding it like an acid or a base will, okay? It takes a bit more time for water to obviously have its effect with what it's reacting with, okay? Reacts with metals to produce H2, all right? Reacts with metals to form hydrogen. That's going to be acid. We're going to see why in another video where we're talking about the naming. It's because acids pretty much always have hydrogen in them, and they're going to replace the metal with a hydrogen ion. All right, they're going to kick that metal out of it and then have H2 come out. All right, these symbols mean, you can see H plus and OH minus. Okay, we're going to really kind of hammer it more later on. I guess I'll point it out real quick here. I did not get my pen up this time, so we're going to kind of go the old-fashioned way. All right. H plus is going to be known as the acid ion, if you want to put that in there, and OH minus or hydroxide is going to be the base ion. Okay. And then when we put those things in brackets, whenever we put any chemical in brackets, we are referring to the concentration of that chemical, which we learned quite a bit about. It's usually in molarity. All right, that is going to be the concentration of that ion present. So in this particular situation, if you have less acid ions than base ions, meaning you have more base, that means this must be a base. Okay, so if the concentration of H plus is less than the OH minus, it's a base. You can obviously tell if it's the opposite, it would be acid. If they're equal to each other, it would be neutral. Baking soda is an example. Baking soda is a base, okay? We will talk about how basically any sort of cleaning type product, okay, is going to be a base. It's going to be a base. The pH scale, all right? The pH scale, if you have a pH less than 7, that's going to be an acid. The pH scale basically runs, at least for generally on-level chemistry, from 0 to 14, okay? And I say that with on-level chemistry because if we taught it in physical science, we go 1 to 14. If you get farther than on-level chemistry and you take it in college, you will see that the pH scale can go anywhere. It can go negative. But we basically say it goes from 0 to 14. 7 is where it is neutral. And so anything less than 7 is going to be acid, and anything greater than 7 is going to be base. Okay? So if we're less than 7, it's an acid. All right? Is an electrolyte? That would be primarily an acid. Okay? That is definitely an acid. It definitely can make things turn on. Okay? Again, electrolyte is something that will conduct electricity when it is dissolved. Acids are almost always dissolved in water, and therefore they will conduct electricity very, very well. All right? A base can be an electrolyte as well because a base is going to be an ionic compound almost all the time. Okay? There are examples where it's not an ionic compound, but it is often an ionic compound, and we know ionic compounds can conduct electricity. Pure water is an example of, we already said it, a neutral compound. Chemical formula starts with hydrogen. I kind of gave a clue about that one. If it starts with hydrogen, that's going to be an acid. Okay, it has to start with hydrogen. I'm not saying it contains hydrogen. All right, we will see. We just showed bases have OH minus, but the H is going to be at the end of the formula. If it begins with H, it's an acid. Produces OH minus, base, base, base. OH hydroxide is our base ion. Changes red litmus paper blue. So if it's turning it blue, blue for base. All right, litmus paper. Litmus paper is something we call an indicator. Wow, is an indicator. Okay, and an indicator is some sort of chemical that changes color in, I didn't want to say based on it, acid or base, in an acid or base. Okay, it'll change color based on whether it is reacting with an acid or a base, or it'll stay, I should say, it should stay a color. It'll have a particular color based on whether it's acid or base. Litmus paper is an indicator, and when it turns blue or stays blue, if we use blue litmus paper, blue for base. Okay, red will be acid. Has a slippery texture. Okay, we said, or I mentioned it briefly, bases are things that we use to clean, soaps, okay, other cleaning products. We will say bases have a slippery texture, okay? Again, bases are used for cleaning. That's the way I want you to try to remember it, okay? Has a pH equal to 7, that would be neutral. Lemon juice, lemonade, all right, things that we generally drink and want to drink. I don't want to encourage you to be drinking anything you shouldn't be drinking, okay? Lemon juice, things that we consume, we will generally put under the category of acids. Again, this is very generalized. There are bases that we do eat, okay? But in general, we're going to say things that we consume are acidic in nature, and then things that we clean with are bases. Has a pH greater than 7, we already mentioned, it's a base. Okay, for Baker is 7. Has a salty or sweet taste or are tasteless. All right. I don't really know why we have that salty sweet. Sorry, that one is, I mean, sure. The tasteless I can get where you're talking about basically it's neutral, okay? I think they're talking about the idea that basically salt itself, like salt water or even some sugar water, doesn't really change the pH too much and you're still basically 7, all right? But the idea is if it doesn't really have a whole lot of taste to it, that's neutral. We're gonna say sour taste is acid and bitter taste is base. A chemical formula ends with a hydroxide, that's a base. There's more H plus than OH minus, that's an acid. If they're equal to each other, that would be neutral. Changes blue litmus paper red, that would be acid. Okay. Vinegar is an example. That's something we add to food, something we can consume, so that would be acid. Is corrosive, that would be acid or base. Okay, obviously if it's not corrosive, we said that was neutral, that was the first one. Has a bitter taste, there you go. Again, another B word, so a lot of B words, blue and bitter, all right? They would be base. Has a sour taste, acid. Ammonia is an example. Ammonia is in a lot of cleaning products, so that would be base. Does not change color of litmus. Well, we said acids and bases do, so this must be neutral. Product produces H plus. If it starts with H plus, that would be acid. Is an ionic compound, that's an acid or a base. Okay, both, because they're electrolytes. And that's it. So, fairly short little video there, just kind of going through. If you need to, rewind, make sure you get them down in your appropriate category.